Hello there, welcome back. This is Professor Rodan and Topics in Mathematics. This is section 8.1, Points, Lines, Planes, and Angles, the first section for geometry. So let us begin with worksheet number 1 as we talk about various definitions, and then we can apply those definitions. Okay, so first of all, I'll talk a little history here with Euclid. Euclid was lived from 320 to 275 BC. And he lived in Alexandria, Egypt. Very famous place historically. And he's famous because he is teacher and scholar and basically applied the logic of the time, the study of logic, apply the knowledge of logic to geometry. So he would be the famous one who actually formalized geometry into, let's say, an academic course, for example, an academic study. So he actually put everything together, put it organized, proved a bunch of theorems, including Pythagorean theorem, and he created the elements. It's a 13-volume masterpiece. Written by Euclid. And this 13-volume masterpiece is only second to the Bible in most translated, published, and studied book in the Western world. Okay, you can read more about Euclid and his elements here from page 436 and 437. Okay, so if you never liked theorems in high school and the proofs of those theorems, you can basically blame Euclid for that. So he's famous for that, or according to your perspective, he could be infamous for having that as a topic of study for all students. All right, well, let's get into the next section, which are some of the definitions. Okay, point, line, and planes. So, actually, these don't have definitions. Okay, so no formal definitions. You may ask why. Well, they just accepted these as obvious. Okay. So, for example, you have point A, and then you have, let's say, a line made up of 2 points. Okay, so that would be called line BC. I'm just going to go over the the symbolism, okay? So this is a point, this is a line. There's also something called a half line. And that basically looks like this. And if we fill in that circle, then you're going to get a ray. Okay. And that can go in either direction, to the right or to the left. Then we have a line segment. Okay. Then we have an open line segment. Or a half, let me do half line segment. And then we have an open line segment. And that will be both endpoints would be open. Okay, so those are points, lines, and then the plane part. Basically, if you have, let's say A, B, which makes a straight line, but then C is not on that line. It's not collinear, so you would see the C over here. Now we have a two-dimensional figure here called a plane. This is a plane. And we can call that plane ABC. Okay. All right. Let's take a look at acute angle. And as we talked about before, so acute angle would be basically any angle that's less than 90 but greater than 0, okay? So we're not going to assume any negative angles here, although that's possible in trigonometry. So this kind of blocks that from any confusion, but if you just remember less than 90, it's fine. So this is actually reading between 0 and 90. Okay, is the correct way to say that. Just remember less than 90 is fine. Just don't include any negative angles. So obtuse angles will be greater than 90, but specifically we have to do greater than 90 but less than 180. Okay? Because 180 is going to maximize our angle, and that makes it straight. Okay, but this is called between. $90 and $180. Okay. Then a right angle, symbolized by the little box-looking figure. That's going to be equal to 90. And then a straight angle. Okay, that means we pushed it all the way until it straightens out, and that's going to be equal to 180. Okay, so we've covered all of our different angles. Now let's go to relationships between two angles. So two angles can be, two or more angles actually can be complementary if they add up to 90. Okay, so if we have let's see here. Actually, we can just do angle 1, angle 2. Angle 1 and angle 2, for example. So this adds up to 90. So angle 1 plus angle 2 equals 90 degrees. Okay. Supplementary angles. Okay, so angle 1 and angle 2. Adds up to 180. Okay, now let's take a look at vertical angles. And that will be two intersecting lines. Okay, so let's say this is angle 1 and this is angle 2. Vertical angles are congruent. Which has this symbol, and all that means is they have the same measure. Oops. Okay. So angle 1 and angle 2, they do not look vertical because the vertical is not really positioned up and down. It is, and this is actually, this position here is actually horizontal, but that's not what this is saying. Okay, it's just a special name so that angles that are across from each other from an intersection like this. Okay, so this angle has like a mirror reflection right over here, and this angle has a mirror reflection right over here. To put it in another way, so angle 1 and angle 2 are congruent. Okay, and if I put angle 3 and 4, for example, then those are congruent. Okay, so you're going to see this a lot more a little bit later. Okay, let's go to now angles of a triangle as a quick reminder. So let's say we have A, B, C. So the angles of a triangle they add up to 180 degrees. So angle A plus angle B plus angle C equals 180 degrees. All right, so those are some of the basic vocabulary that we talked about before. Just want to lay that out, give you some visuals and some reminders. So let us proceed to applying some of these in the next page. Okay. So I'm going to do the odds, and what I'm going to do is put the relationships on the left and the math on the right. Okay, so for example, number 1, angle 1, which is here, is 76 degrees. And angle 3, which is here, is what? So notice the relationship, they're across from each other in an intersection, so these are vertical. And since they are vertical, we know from the previous page, vertical angles have the same measure or they're congruent. So we're just going to write 76 degrees. Number 3, angle 2 is right here. It's 112 degrees. Angle 4 is right here. Oh, another vertical relationship. So these are also congruent or the same measure. Oops. Number 5, angle 11 is equal to 53. What is angle 12? Oh, another vertical relationship right there. So those are also congruent or the same measure. So we're just going to copy down the exact same amount. Okay, number 7, angle 5. Where's angle 5? Angle 5 is right here. Angle 6 is right here. Okay, those are not vertical this time. But as you can see, if this is a straight angle, so that's 180. This is 90, so this must be 90 as well. Okay, so we can assume that this is 90. And 6 and 5 basically are complementary. And if they're complementary, they add up to 90. So all I gotta do is do 90 minus 36, and that's gonna give me 54 degrees. Okay, whoops. Okay, let's take a look at number 9. Angle 7 is right there. Angle 8 is right here, 64 degrees. And then what is angle 9? So angle 9 is the missing angle in our triangle, and we know that those add up to 180. Okay, so we can just shortcut that, and just write supplementary. Since we're using the number 180, it's fine. So I'm just going to say over here, supplementary, 3 angles that add up to 180 because it's in a triangle. So I'm giving 2 clues. So if I do 180 minus those 2 clues, which is 73 and 64, that's going to give me, just add those 2 up and get 137, and that's going to give me 43. Okay, so 43 is the third angle that was missing to complete the 180 degree sum of all the angles. Now let's take a look at 11. So let me get this out of here. So this time they give us angle 7, angle 9, and we're missing angle 8. So same question, just different clues and different angle we have to find, but it's the same exact process. 180 minus the two clues, or the two angles. And that's going to be 65 degrees. Okay. Next we have number 13. Number 13, okay. So angle 11 is here. That's 55 degrees. And angle 10, what is angle 10? Well, this time they only give us one clue. But if you look at this specific triangle, we actually have already in the diagram the second clue, which is this symbol here, which means it's a right angle, 90 degrees. So technically we have, we're supposed to find angle 10 right there. So we have, again, three supplementary angles. So we're going to do 180 minus the 90 degrees plus the clue that they gave us, 55. And that's going to be 180 minus 45, which is 35. Okay. Angle 15, number 15. It says angle 10. Okay, that's 30. We know this is 90. And then it's asking you for the angle on the outside. Okay? So, to find 13, we actually have to find 11. We got to find 11 first, so then we can find 13 second. Okay? So let's do the same process. Wait. So let's find angle 11 first. So angle 11 is, that one's the third missing angle. So 180 minus 90 plus 30. And that's going to be minus 120. So angle 11 is actually 60 degrees. Okay. So 60 degrees is basically here. And so now, so the first relationship was supplementary for the straight angles. And if you look at 11 and 13, that's another wait, that's not right. Supplementary for the triangles, my bad. Supplementary for the angles of a triangle. And then to find angle 13, that's a straight angle. So again, supplementary. For straight angles. So 180 minus the 60, that's going to give us the 120. Okay. Okay, great. So we're applying many definitions here, and using those definitions to find missing angles. So let's go to the next section. As you can see, the next page are solving equations. So let's do the same thing, but we're going to be solving equations this time. Okay, so again, we're going to do the odds. So 17, let's take a look at the relationship here, and the relationship is going to guide us to build our equation so that we can find x and then find the measure of each angle. Okay? So, if you look here, we see that these are complementary angles. And therefore, we need to add up these two expressions. So, this angle is x plus 6. This angle is x. If you add those up, you're going to get 90. Okay. So once you build your equation, solve it. Okay. So first, build equation. Using geometric relationships like complementary. And then 2, solve it. Or solve for x. And 3, find each angle. Okay, those are your 3 steps. So we did step 1, they're complementary, and we built the equation. Now we're going to solve it. So we see some like terms right here. So that's x plus x is 2x. 6 stays on the left, the 90 is still on the right. And notice that we combine those x's because they're on the same side of the equal sign. They're on the left side. So we're allowed to just put them together in one basket there. So x and another x makes 2 x's on the same side. Now we're going to solve for x. So we're going to subtract the 6 from both sides and then divide by 2, okay? Because we want x by himself. Let me not do that. We want this by himself. So let's get rid of him. And that leaves us with 2x on the left and 84 on the right. And now let's divide by 2. And now we get 42. Okay. So we're going to take that's step 2, solve for x. Now we're going to find each angle by placing this x here and here. Okay, so we can easily find the first angle there because it's exactly the same as x. So actually, let me make some room here. So this is just 42 degrees. And this is going to be 42 plus 6, which is 48 degrees right there. Okay? Okay, let's take a look at number 19. And if you can see, this is a straight angle, which both angles add up to 180, so these are called supplementary. Supplementary angles. And so we're going to take our 2 expressions and add them up. So 2x plus, that's one angle. The other angle is 5x plus 12. And that's going to be equal to 180. So again, we're going to combine like terms. right here and here, those are like terms because they have x's to the first power. So 5x plus 2x is going to be 7x. Then we're going to solve for x. So we're going to get rid of the 12 and the 7 one step at a time. So let's subtract the 12 first. And that, we're going to subtract it on both sides, and that's going to give us 168. And then divide by 7. That's going to give us 168 divided by 7 is 24. Okay, so this is our x. So we need to plug that x in to both angles here. So the first angle is just going to be double that. So it's going to be 2 times 24, which is 48 degrees. And then the second angle is 5 times our answer. So 5 times our answer plus 12. That's going to be 120 plus 12, which is 132. And those are our two angles, 48 and 132 for number 19. Okay, let's do number 21. And as you can see, these are complementary. Complementary angles. So we're going to add up these expressions to so that's the first angle plus the second angle, and that is going to be to 90. Okay, so we're going to combine like terms. We have our x terms here, which is going to be 4x. And we also have constant terms. We have that one and that one there. So 15 minus 5 simplifies to 10. And now we can solve for x. So we subtract 10 from both sides. That's 80, and then divide by 4 on both sides. And that's going to be 20. Okay, so since x is 20, we're going to put those here and here. So the easier one is the one on the bottom, so 20 minus 5, that's 15 degrees. And then put our 20 over here, 3 times 20 plus 15. So that's going to be 60 plus 15, which is 75. Okay, and our last one for this page is number 23. As you can see, this relationship is called, since they're across from each other, these are called vertical angles. And vertical angles are congruent. So that means we're going to take our expression 6x and make it equal to 4x plus 20. And we're going to, now the x's are not on the same side, okay? So this is already simplified. But we do need to get x's on one side. And you cannot simply add 6 and 4 to get 10 because they're not on the same side. You're not allowed to do that. Okay, these are opposite sides. So to bring one term from one side, let's say from the right side to the left side, you must do the same thing to both sides. So in other words, if I want to move the 4x to the left, I have to subtract it out first from the right and then rewrite it as well on the left. So it's gone from the right side, but now on the left side it's going to be 6x minus 4x, which is 2x. And then I can divide by 2 on both sides, and that's going to give me 10. So we're going to place this here, which is the easier version. 6 times 10 is going to be 60. And we could put the 10 here as well, but this is not necessary because we already know, since they're vertical angles, they're congruent. So if we know that this is 60, then this has to be 60. Okay, so both are 60 degrees. Okay. All right, so that's it for this section. Let's go to the other section, which also has some definitions as well.